The images show a high voltage switch used for connecting or disconnecting a power line. These switches are typically found on utility poles and play a crucial role in power distribution. The switch is operated manually using a long insulated stick, sometimes referred to as a hot stick. This stick is inserted into a designated point on the switch mechanism, allowing a lineman to safely open or close the switch from the ground or a bucket truck. The provided photos illustrate the switch in both the closed and open positions. When the switch is in the closed position, electrical contacts are physically touching, creating a continuous path for electricity to flow through the power line. This allows power to be transmitted along the section of the grid. Conversely, when the switch is in the open position, the electrical contacts are separated, interrupting the flow of electricity. This effectively disconnects that section of the power line from the rest of the grid. High voltage switches serve several important functions within the electrical power system. Firstly, they are used for isolating sections of power lines for maintenance and repair. When a fault occurs or when work needs to be performed on a specific section of line, these switches can be opened to de-energize the area, ensuring the safety of the workers. Secondly, these switches facilitate the addition or removal of new sections of power line. When a new line is being connected to the existing grid, a switch can be used to safely integrate the new section. Similarly, if a section of line needs to be removed or bypassed, a switch can isolate it from the rest of the system. Thirdly, high voltage switches can be used to reroute power flow in the event of an outage or other disruption. By opening and closing switches at strategic locations, power can be redirected to maintain service to critical loads. The operation of these switches is carefully coordinated by system operators who monitor the flow of electricity throughout the grid. They use sophisticated software and communication systems to ensure that switches are operated in a safe and efficient manner. The design and construction of high voltage switches are critical to their reliable operation. The switches must be able to withstand high voltages and currents, as well as the environmental conditions to which they are exposed. They are typically constructed of robust materials such as porcelain or polymer insulators and heavy-duty metal contacts. The switches are also designed to minimize the risk of electrical arcs and other hazards. The maintenance of high-voltage switches is an important part of ensuring the reliability of the power grid. Regular inspections and testing are performed to identify any potential problems. The switches are also lubricated and cleaned to ensure that they operate smoothly. If a switch is found to be faulty, it is typically replaced or repaired as soon as possible. The safety of linemen and other workers is paramount when working with high-voltage switches. Strict safety procedures must be followed to prevent electrical shock and other injuries. Workers must be properly trained and equipped with the appropriate personal protective equipment, including insulated gloves, sleeves, and hard hats. The use of hot sticks and other specialized tools is also essential for safe operation. The switches themselves are often equipped with safety features such as grounding hooks and interlocks to further reduce the risk of accidents. It is important to note that high voltage switches are just one component of a complex electrical power system. Other important components include transformers, circuit breakers, and protective relays. These components work together to generate, transmit, and distribute electricity safely and reliably. The National Electrical Code, or NEC, provides guidelines for the safe installation and operation of electrical equipment, including high-voltage switches. Specific articles and sections within the NEC address the requirements for clearances, grounding, and overcurrent protection. For example, NEC Article 490 covers requirements for equipment over 600 volts nominal. This article includes details on spacing, guarding, and workspace around electrical equipment. NEC Table 310.16 provides ampacity ratings for conductors based on insulation type and ambient temperature. This table is used to determine the appropriate size of conductors for carrying electrical current to and from the switch. NEC Section 250.184 covers grounding requirements for systems over 1000 volts. Proper grounding is essential for preventing electrical shock hazards and ensuring the safe operation of the equipment. The specific requirements for high-voltage switchgear can vary depending on the application and the local regulations. It is important to consult with a qualified electrical engineer or inspector to ensure that all applicable codes and standards are met. In addition to the NEC, other standards organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI, publish standards related to high-voltage switchgear. These standards provide guidance on the design, testing, and operation of the equipment. For example, IEE Standard C37.22 covers metal-clad and metal-enclosed switchgear. This standard includes requirements for construction, testing, and performance. ANSI Standard C37.30 covers switchgear, switchboard, and substation apparatus. This standard provides definitions and terminology related to switchgear equipment. The proper selection, installation, and maintenance of high-voltage switches are critical for ensuring the reliable and safe operation of the electrical power grid. These switches play a vital role in connecting and disconnecting power lines, isolating equipment for maintenance, and rerouting power flow during emergencies. Understanding the operation and function of these switches is essential for anyone working in the electrical power industry. The voltage rating of the switch is a crucial parameter. This specifies the maximum voltage the switch is designed to handle safely. Common voltage ratings for distribution systems include 12.47 kV, 34.5 kV, 69 kV, 115 kV, 138 kV, and 230 kV. The switch must be rated for the system voltage to prevent insulation breakdown and potential flashovers. The current rating of the switch indicates the maximum continuous current the switch can carry without overheating. This rating is determined by the size and material of the switch contacts and conductors. Common current ratings for distribution switches range from 600 amps to 3000 amps. The interrupter rating of the switch is the maximum fault current the switch can safely interrupt without being damaged. This rating is much higher than the continuous current rating and is determined by the design of the switch's arc extinguishing mechanism. The interrupting rating is typically specified in kiloamps. The type of switch operating mechanism also varies. Some switches use a manual operating mechanism, where the switch is opened and closed by hand using a hot stick. Other switches use a motor-operated mechanism, where the switch is opened and closed remotely using a control system. Motor-operated switches are often used in automated substations and distribution systems. The insulation material used in the switch is also important. Porcelain is a common insulation material used in high-voltage switches. It provides high dielectric strength and is resistant to environmental conditions. Polymer insulators are also used in some switches. They are lighter than porcelain and offer good performance. The switch contacts are typically made of copper or aluminum. Copper contacts offer good conductivity but are more expensive than aluminum. Aluminum contacts are lighter and more cost-effective but have lower conductivity. The switch enclosure protects the switch mechanism from the environment. Enclosures are typically made of steel or aluminum and are designed to prevent the ingress of water, dust, and other contaminants. Some enclosures are also designed to provide shielding from electromagnetic interference. The grounding system is an essential part of the switch installation. The switch must be properly grounded to protect workers from electrical shock and to prevent damage to equipment in the event of a fault. Grounding conductors are typically made of copper and are connected to a grounding grid or grounding electrode. The switch control system allows operators to remotely monitor and control the switch. Control systems typically include features such as status indication, alarm annunciation, and remote operation. Control systems can be integrated with SCADA systems for centralized monitoring and control of the power grid. The switch testing and maintenance program is crucial for ensuring the reliable operation of the switch. Testing and maintenance activities typically include visual inspections, insulation resistance testing, contact resistance testing, and operating mechanism testing. Regular maintenance can help to identify and correct potential problems before they lead to equipment failures. The environmental conditions at the switch location can affect the switch performance. Switches located in areas with high humidity, salt fog, or pollution may require more frequent maintenance. Special coatings and enclosures can be used to protect switches from harsh environmental conditions. The switch location and accessibility are important considerations. Switches should be located in areas that are easily accessible for maintenance and repair. The location should also be free from obstructions and hazards. The safety procedures for working on high-voltage switches must be strictly followed. Workers must be properly trained and equipped with the appropriate personal protective equipment. Safety procedures typically include lockout-tagout procedures, grounding procedures, and clearance procedures. The cost of a high-voltage switch can vary depending on the voltage rating, current rating, interrupting rating, and other features. The cost of installation and maintenance should also be considered when selecting a switch. The lifespan of a high-voltage switch can vary depending on the operating conditions and the maintenance program. With proper maintenance, a high-voltage switch can last for many years. The switch standards and regulations are constantly evolving. It is important to stay up to date on the latest standards and regulations to ensure that switches are installed and operated safely. The switch suppliers and manufacturers can provide valuable information on the selection, installation, and maintenance of high-voltage switches. It is important to choose a reputable supplier or manufacturer with a proven track record. The switch training programs are available for workers who install, operate, and maintain high-voltage switches. These training programs can help to ensure that workers have the knowledge and skills necessary to perform their jobs safely and effectively. The switch innovation and technology are constantly advancing. New switch designs and technologies are being developed to improve the performance, reliability, and safety of high-voltage switches. The high-voltage switch is a critical component of the electrical power grid. Understanding the operation and function of these switches is essential for anyone working in the electrical power industry.